So for the next 2 hours or so, we're going to discuss what is arguably probably the biggest problem, for lack of a better word, we have in post-tensioning, whether it's beams and slabs, one-way slabs, two-way slabs, podiums, whatever you have. Restraint to shortening, I think, is our biggest issue. If we could, successfully get rid of it, I think we'd get real close to having, the crack-free, perfect structural system that some salespeople will talk to you about, but it's one of those things where it is an issue that, if not taken care of in the design phase or in the construction, it's constructed poorly. The slabs and or walls can crack and crack severely. And while we can all make the argument that some of these cracks may not be structural in nature, when the owner and or architect sees pretty substantial cracking, it's hard to argue they're non-structural and, no big deal. It sounds like you're just trying to sell something. So anyway, if this webinar spurs your interest, my business partner and I, Dirk Bonnie, wrote a book during the recession, and we've kept it going. The book is partitioned basically into the undergraduate class that we teach at a few universities, which is the first half of the book, which is all the principles and what you hopefully should have had or didn't have in undergraduate. The second half is what we use PT for in the real world, design examples, real design examples, detailing, stuff like that. And we have a specific chapter 13, which is the, unlucky chapter for RTS, because again, this is the thing that it's non-numerical, but again, if there's something that's going to crack your post-tension building, I would say 9 times out of 10, it's an RTS issue that is causing you the concern and the letter writing. The nice thing, or at least the comforting thing about restraint cracks, is this is not a new thing. We didn't, just discover it during COVID because we had nothing else to do. It's been around for a while. There was a document that was presented at the ACI convention in '86. That was authored by Bijan Alami and Florian Barth, that basically addressed this issue and what to do to minimize the crack. So again, it's been a consistent issue. We haven't, it's not that it's going to be solved, but they can be minimized. But again, this has been something that's been kicking around for a while now. The people, including myself, of the PTI group that is DC20, which you can see right here, we updated the manual or this document a few years ago and, included some new different things and tried to, adjust it and make it more for the current times. The results are still the same, but there's just some additional information. So again, if you are overly interested, there is a new document. I believe it came out in 23 or 24. So it's still relatively new. There's a lot of great pictures, a lot of great discussions about the topics, what to do, what not to do, and stuff like that. So if you are interested, it's, I think, 50 or 60 pages. I don't believe it's that overly expensive, but if you're new to PT, I would definitely recommend having that as a good reference point. Now, restraint to shortening, or what we refer to as RTS, is conceptually not a PT issue per se. It's not like because it's PT, all of a sudden you get RTS. RTS is a function of concrete in general. So all concrete, whether it's PT, precast, cast in place, whatever it is going to shrink and move. That's the curing process. That's the hydration process. Concrete as a material is going to shrink and move. There's something magical about that changes with post-tensioning. Now, having said that, the pre-compression that you put in from PT will, obviously add a little oomph to the section. It's going to compress it, obviously. That's going to make it move towards, let's say, the center a little bit more. Roughly speaking, it's about 20-25% more than, let's say, the equivalent rebar-only slab, which again is somewhat of an odd way to put it, because typically PT systems are thinner than a rebar deck, and typically larger decks obviously have more concrete and are more susceptible to movement. But in general, the PT will increase the movement a little bit. Now, in a global sense, the primary financial benefit of PT is that we can have thinner slabs, which again is great for seismic, for foundations and columns. But I think, at least my understanding from the contractors I deal with, it's the reduction, the significant, they say massive reduction in rebar is where the contractors or the owners are going to save all the money. So when you don't have this continuous top and bottom mat each way of rebar, which you're going to have in a rebar only system, when something cracks, especially on the top, there's really no rebar outside of, let's say, 5 or 6 feet from the column face to pull that crack back in and resist it. So while rebar only systems will have restraint to shortening, typically a two-way rebar only slab is going to have top and bottom rebar each direction all over the place. Now, if you've ever seen one, which I'm sure a lot of you have, if not all of you, in a rebar only system, you can walk from one side of the deck to the other and never touch the formwork because there's just so much rebar all over the place. Now with PT, that's definitely not the option. There's really no top rebar in two-way slabs except at the column. So I mean, you're walking on all the formwork. So again, when you see that, obviously the rebar top especially is going to catch those cracks. We don't have that, which again is the primary financial benefit. But then that makes us much more susceptible to cracks in the concrete because we don't have 5s to 12 each way, each face. So conceptually, it's not a PT issue. In reality, because of the nature of the beast, it is a PT issue. So it's kind of a yes and no answer. Now, how do we solve this? Well, RTS can be minimized by a couple ways. One, and the first one, is a good shear wall layout. Well, I'll cover that in a little bit. I will say this. You have shear walls typically for concrete buildings, or you have moment frames. Obviously, shear walls are a lot stiffer than a moment frame. I think you probably argue 10 to probably plus times stiffer. Not that this isn't an issue with moment frames, but again, the stiffer the system, the more restraint you're going to have. So I would say primarily it's a shear wall issue, not so much a moment frame issue. So a good shear wall layout, which we'll cover, is huge. Slip detailing, is equally as important. And then obviously with anything we do, constructing our, beautiful details and making sure they don't have the bond or the other things that we're trying to do, that's, equally as critical as the other two. So when we do observations on PT slabs, obviously prior to the concrete placement, I probably spend equal amount of time checking slip details as I do with checking profiles and rebar and, proper placement. Because again, in my experience, and I don't think this is unique, the RTS stuff is what's going to cause the cracks. It's not structural, they're shrinkage cracks. But again, those are the things that are going to get you dragged back out there to start writing letters and all that kind of good stuff, because no one really can see a crack for differently than what it is, which is a crack.